Good morning, students. We have been seeing this unit 5, that is the radiation. So now I will quickly review what we have seen in the last lecture. The last lecture, we have seen an introduction to radiation. When we speak about radiation in heat transfer, we speak about the thermal radiation range. In the thermal radiation range, your wavelength will range from 10 to the power of minus 1 to 10 square. Okay, this is the range in which thermal radiation will be. And in heat transfer, we will be interested only in this particular range. In the whole electromagnetic spectrum, we will not be dealing with the other kinds of radiation, other wavelength ranges like visible range, X-rays, ultraviolet rays, microwaves, gamma rays, blah, blah, blah. So many things will be there. Okay, all those things will not be taken care in the thermal radiation part. In thermal radiation, we are dealing only with the 10 to the power of minus 1 to 10 square, that is thermal radiation range. We are interested only in that part. Okay. Same thing we have seen here. It is zero point 0.1 to 100 micrometer wavelength. Okay, so that's what we have seen. Also, we have seen this concept here. We have taken a body. On a body, there is an incident radiation, and this incident radiation is reflected and it is transmitted and absorbed also. So there is a reflected part, there is a transmitted part, and then there is a absorbed part. So whatever Q you have, it can be written like summation of these three. This is how you can write for your Q. And then we have gone to define what is the reflectivity, and we have shown it with a rho. Reflectivity is a fraction of incident radiation that is getting reflected. Okay. Then we have defined what is transmittivity. Transmittivity is a fraction of incident radiation that is getting transmitted. Absorptivity, fraction of incident radiation that is getting absorbed. And we have taken this one, the summation that we have taken previously, we have used that to get this correlation, that is the sum of this reflectivity, transmittivity and absorptivity will be equal to 1. This is what we have seen, and then we have gone on to explain what is the classification for radiation bodies. So first thing what we have done is we have made use of alpha, rho and tau and epsilon to actually get this classification. For that, we have taken white body. White body will be a perfect reflector. Its reflectivity will be equal to 1. The other things will be equal to 0. Then we have defined what is a black body. Black body is a perfect absorber. So perfect absorber will have alpha is equal to 1. The other two will be equal to 0. The transparent body we have seen. The transparent body is a perfect transmitter. So it will have perfect transmittivity. That is transmittivity is equal to 1, and the other two will be equal to 0. And the opaque body we have seen, opaque body will not have any transmission. So tau will be equal to 0, and the sum of the other two will be equal to 1. Further, we have seen what is a real body or a non-black body. For a real body or non-black body, the value of the absorptivity, reflectivity, and transmittivity will not be equal to 0, and it will be less than 1. And sum of these three will be equal to 1. That's what we have seen for a real body or a non-black body. Further, we have seen gray body. The gray body will have epsilon less than 1, and epsilon will be equal to emitted radiation of a non-black body to the emitted radiation of a black body. So that's what emissivity is. So for a gray body, emissivity will be less than 1. For a black body, emissivity is equal to 1. So simply speaking, the black body is perfect absorber and perfect emitter. So the emissivity will be equal to 1 for black body. At the same time, the alpha will also be equal to 1 for black body. That's what we have written here in B, right? So quickly moving ahead, we have seen the classification based on the reflection of the body. So first what we have seen is a specular body. The specular body, the angle of incidence with respect to the vertical will be equal to the angle of reflection with respect to the vertical. That is theta I is equal to theta r as shown in this diagram here. Uh, with the same angle that it is being incident, with the same angle, it will be reflected. So that we call it as a specular body. That's why it is called as a angle dependent reflection bodies. Also, we have seen diffusive bodies. Diffusive bodies are like it will diffuse in all directions. Whatever the reflection that is taking place, that reflection will be there in all directions, as shown in this diagram here. So that's why these diffusive bodies are called as angle independent reflective bodies. So that's what we have seen, and we have seen the laws of radiation here. Wein's displacement law, Stephen Boltzmann law, and Kirchhoff's law. We have seen lambda t is equal to 2898 is the Wein's displacement law. Stephen Boltzmann law is anyways very much well known to us. Kirchhoff's law says that for a non-black body, emissivity will be equal to the absorptivity. And Planck's law of radiation also we have seen. This is the thing that these constants you need not remember. These constants will be available to you in your data book. So moving ahead, what we have is a shape factor. This is a concept that I told you is very important thing. So let us spend time here today. So I'll slowly tell you what we have seen in the last class regarding this shape factor. So regarding shape factor, we have taken a body 1 and a body 2, and body 1 will be emitting a radiation. Whatever the emitted radiation is there, a part of it is taken by the other side, that is body 2. Okay, so here Q1 is the energy emitted by the body 1 and Q2 is the energy emitted by the body 2. When I take Q12, మీరు ఇక్కడ కాల్ చేయదు. Don't make noise, please. I'm taking class here. So if I take Q12, energy emitted by the body 1 and received by the body 2. So that's what the meaning of Q12. If I take Q21, it is energy emitted by the body 2 and received by the body 1. Okay. Shape factor is a here we have taken the definition of shape factor. Shape factor is a fraction of radiation that is diffused and received from one surface on the other surface without any intermediate reflection. That is directly it is going to hit the other side. That's what we have seen. Then we have written F12, that is the shape factor of body 1 with respect to the body 2. F12 will be equal to Q12 by Q1. That's what we have seen. F21 we have seen, that is shape factor of body 2 with respect to body 1. So that is equal to Q21 by Q2. Same thing we have repeated. Then we have seen the properties or characteristics of the shape factor. The shape factor depends on the geometry of the body. That is, if I take the same kind of body like 1 and 2 with the same area, that is A1 is equal to A2 is equal to A3 is equal to A4. In that case, F12 will not be equal to F34, meaning it is depending on the geometry of the body. The shape factor is depending on the geometry of the body, and shape factor will also depend on the orientation. The same bodies 1 and 2, if I have inclined, that is A1 is equal to A2 is equal to A5 is equal to A6, then A12 will not be equal to A56. So this will be the second property of your shape factor. That is, shape factor will depend on the orientation. And then other property is that the shape factor will range from 0 to 1. So it will be always between 0 to 1. And one more thing is the sum of shape factors of a body with respect to the surrounding bodies is always equal to 1. So I have taken 2, 3, 4, 5, 6 bodies here. So if I take sum of shape factors with q12 plus q13 plus q14 plus q15 plus q16, so that will be equal to q1. So if I take the shape factors, all the shape factors will be equal to 1. The sum of all the shape factors will be equal to 1. So shape factor of a body with respect to itself, if we take f11 will be equal to 0 for flat surfaces. If I take a flat surface like this, then f11 will be equal to 0. And uh, for convex surfaces also, if I take this one here, this is a convex surface. So for this one also, whatever the emitted radiation is there, it is not taken by itself. That's why we call the f11 equal to 0. And if we take concave surface, the concave surface is the third one here. Here in this case, whatever the emitted energy is there by that body is taken by that body itself. Okay, if we take the emitted radiation by itself, that's why it will be not equal to 0 for concave surface. So that is the thing. So till here, we have seen already in the last class. So next thing that we are seeing is the reciprocity theorem in respect to our shape factor. Okay. What does this reciprocity theorem say? It says this thing: A1 into F12 is equal to A2 into F21. So let me explain this. If I take a body 1 here, and if I take a body 2 here, this is a body 1 and this is body 2, and there will be heat exchange by radiation between these two bodies, and let us say the areas are different. If that is the case, how they will be correlated? This is how they are correlated actually. A1 F12 is equal to A2 F21. This is what the reciprocity theorem is saying. So what it is doing, essentially it is bringing the area into the picture, and with area it is trying to correlate the heat exchange that is happening with 1 to 2 and 2 to 1. This is 1 to 2, f12 is 1 to 2, and f21 is 2 to 1. That's what reciprocity theorem is helping you out. Okay, so how do I get this actually? How do this expression is obtained? If you have to look at that, for that what we have to do is we must take the heat transfer by radiation on both the bodies. Okay, this is one, this is two, let us take. If that is the case, what is the heat transfer by radiation formula? We know that it is E sigma into A into T to the power of 4. This is T1 here. On the other side, sigma into A into T2 to the power of 4. This will be area 2 and this will be area 1. Anyways, the sigma will be same for both the things. But here, in order to equate these two, what you should take is you should take something called as shape factor. That's the important thing here. So shape factor you have to take on both sides. F12 on one side, F21 on the two side you have to take. That's how we will take this. Now I can cancel out what is the constant, that is sigma. Then if I assume T1 is equal to T2, if I assume that T1 is equal to T2, then I can cancel out T1 power 4 and T2 to the power 4 also. Then what happens is I will get the expression for reciprocity theorem F12A1 is equal to F21 A2. So this is the reciprocity theorem. This is very important while solving the problems based on the shape factor. I hope that is clear to you. Let me move forward and let's see a few more properties regarding the shape factor. Let me take a vertical body here. This is like your body one, and then I'll have body two now. This is my body two. Now what I will do is I will divide the body one into two parts and call this part as 3 and this part as 4. If this is the case, let me call this as emitting body and this body as a receiving body. If this is what is happening here, then what I can do is I can write my F12 as summation of F32 plus F3, sorry, F4. So what I'm doing is F12 means the whole body 1 is emitting heat to body 2. Now, if I take F32, what is this? This is a half part maybe, or some portion of 1 is sharing with the 2, and 4 is the other portion of 1 is sharing with the 2. So obviously the share factors will be taken like this because share factor is nothing but the amount of heat exchange that is happening between a body with the other body. So this is the thing. Now, uh, if I take the other case here, let me call this as body 1, this as body 2, and this I am dividing it into 5 and 6. So here what I get is F12 is equal to F15 plus F16. What I will do is this is emitting body and this is a receiving body. If this is the case, I can write it like this. Okay, these are actually kind of intuition kind of things. Okay, we have to actually verify whether these things are true or not. Okay, we tend to think of shape factor like this. Whether this is right or wrong, we actually have to verify. For verifying the same, what I will do is, for the first case, I'm taking Q12 is equal to Q32 plus Q42 is the actual thing. The heat transfer is like this. If this is the case, in terms of share factor, I can write it like A1 F12 into sigma into T1 to the power 4 I can write. Okay, this will actually get cancelled on both sides. So I will not write sigma t to the power of 4. Simply I will write A1 F12 is equal to A3 F32 plus A4 F42. So this is what I will be writing. So this is a thing here. Your hypothesis is your hypothesis. You have written that F12 is equal to F32 plus F42. This is what we have written. So if both the statements are to be true, let me say that this is true. If 1 and 2 are to be true, then A1 should be equal to A3 is equal to A4. Then only both the equations will suffice. Okay, both will be true only if A1 and A3, A4 are equal. Is A1, A3, A4 equal? Can somebody tell me? Look at this. A1 is equal to A3 is equal to A4. Is this right?
No, sir.
No, it is not at all right. So, whatever you have taken as your hypothesis is not correct. This is not correct. So, your shape factor cannot be written as a sum like this. This is a one more important property of a shape factor that you should keep in mind. Okay. So, that's the important thing here. Then, how about the second case? Okay, if I divide the receiving body into two parts, whether this hypothesis is right or wrong, let us cross check. For the same thing, what I will do is I will take Q12 equal to Q15 plus Q16. So for verifying my hypothesis, I have taken this Q12 is equal to Q15 plus Q16. So if I write this on this side, A1 into F12 into sigma into T to the power of 41 to the power of 4. The other side also sigma to the power 4 will come. I'm not writing that part directly. I am moving to this one. No, no, it will be good if we write this here. Then only we will be able to understand it here and write it. A1 F1 5 into sigma into T to the power of 5 plus A1 into F16 into sigma into T1 to the power 4. This should not be 5, this should be 4. Mm. So, if this is the case, sigma T1 power 4 will be taken out. A1 into sigma into T1 to the power 4 can be taken as common. So, what you have is F12 will be equal to F15 plus F16 you will have. So what is this expression? This expression is nothing but your hypothesis. So here you have written your hypothesis. This is what you have written. So what you can say is this hypothesis is correct. So from all this discussion, what we can write is we can write 2 points here. If emitting body is divided into two portions. Sum of individual shape factors is not equal to total shape factor. Let me write this clearly. This emitting body. The same thing if I repeat now. This thing is creating a problem. Write it. If receiving body is divided into two or more, you can write portions, sum of individual shape factors will be equal to the total shape factor. I hope this is clear to you. There's nothing great actually. If you have any questions, you can ask. Otherwise, we will proceed to the next property of the shape factor. Any questions? I'll assume no questions. So let me take one more case for shape factor here. So for that, what I'm doing is I'm taking body 1 with some length and body 2 with some other length. This is my body of 1 and this is my body 2. If this is the case, what will be the shape factor? F1 into. For this, how is it? Is like sum of crossed strings minus sum of uncrossed strings by 2 into L1. Okay. So let me explain this to you here. What is a crossed string? What is uncrossed string? So crossed string means what we have to do is we have to take a length from here to the other edge, from one end to the other edge, this edge to this edge, and then this edge to this edge, and this edge to this edge. If this is the case, okay, this one, let me call it as L1. This length I'm calling it as L1. This length I'm calling it as L2. And then this I'll call it as L3. This I'll call it as L4. This I'll call it as L5. This I'll call it as L6. So length I have taken here. So here what I'll do is crossed strings means what here? Can you see? This 3 and 5 are actually crossed strings. So what I can write here is length 3 plus length 5 I can write minus uncrossed means 4 and 6 are uncrossed strings here. So what I get here is L4 plus L6 by 2L1. So this will be the formula for finding the shape factor if you are given bodies with these two lengths. Okay, different lengths are given. This is how you will find out the shape factor. And you can also find out F21 also. What will be F21? Can you guess? It is same actually. The only in place of L1 you have to change it to L2. That is the only change you will get for F21. So the numerator remains the same. L3 plus L5 minus L4 plus L6 by 2L2. So this will be the formula for F21 also. So in a given problem, he'll be giving you the lengths in the question. L1, L2, L3, L4 is lengths. You have to find out. L1, L2 will be given, and remaining things you have to find out and solve for the shape factor. Okay, that is one case. Let us move on to the other case of the shape factor. If you have bodies inclined like this is a body one, this is your body one, this is a body two, and they are inclined with an angle theta. So for what we have seen is we have seen only parallel things. Now here we have an inclination thing here. So if L1 is equal to L2, then F12 will be equal to 1 minus sine theta by 2 sine theta by 2. That is the F12. So what will be the formula for F21? The same formula you will have. It won't vary because lengths are equal. F12 is also uh, F21. What if L1 is not equal to L2? If this is the case, what you have to do? You have to use graphs and solve the question. Okay, you don't have any shortcut for that. You have to use graphs and solve it. Okay, so this if L1 is not equal to L2 will not be given for competitive exam. This is for the semester exam. Or okay, let's move to the next case. So from now onward, we will take some real cases. If the given problem that we have taken in the previous case, it has 90-degree angle. So what will be the shape factor value? F12 or F21, both are anyways equal. That is equal to 1 minus sine 45 degrees, 90 by 2. So that is 1 minus 1 by root 2 is your F12 formula, F12 value. Okay, like that you can make use of that. Let's move to the other case wherein you will be having three surfaces kept together with some inclination in form of a triangle. So here you take this body 1 with the length L1, this body 2 with the length L2, this body 3 with the length L3. Outer side will be insulated anyhow. Only inside heat exchange we are interested in here. So if this is the case, what will be the formula for F12? If I have to write this will be equal to L1 plus L2 minus L3 by 2 into L1. This is a F12 formula. Okay. So can you guess what will be the formula for F23? Please tell me.
L2 plus L3 minus L1.
Correct. L2 plus L3 minus L1. What is in the denominator?
2 2.
2, 2L2. Correct. So the same way you can write the shape factor. You will get 6 shape factors, 6 combinations you will get here. All those things you can write here. I'm writing it for F13 here. F13 will be equal to what? L1 plus L3 minus L2 by 2L1. Also, I can write it for F31. Quickly write it for yourself. It is L3 plus L1 minus L2 by 2L3. F3, 2 I can write. This is equal to L3 plus L2 minus L1 by 2L3. F21 I will write. This will be equal to F, sorry, L I should write here L2 plus L1 minus L3 by 2L2. This is kind of an extension to your crossed string case. Okay, the similar kind of thing only. If it is uncrossed, you'll get minus kind of the same thing. Similar thing. You cannot say same, but it's kind of similar story. Right. Moving ahead, let's solve a question here. So let me write that question here. Determine the shape factor of inside surface of a hemispherical body. Spherical body with respect to itself. So that's the question. Solve it and tell me what is that F11 value he's asking. Is the question clear to you? There is a body 1 here. Okay. It's not equal to 1 anyways. There is a body 1 here. And this body is a hemispherical body. And we have to find the shape factor of this body for its inside surface with respect to itself. Guys, can you solve this? You have a spherical body here. Okay, it's a sphere here. Okay, I cannot. So this is your hemisphere here. Let me call this body as one. To understand the F11, I will imagine a body here that is enclosing the surface here like this. Okay, this I'll call it as body 2. This is my body 1. Let me take that it is exchanging some heat with body 2. See, this is actually not given in question, but I am imagining for actually solving it. Okay, I will make use of the various properties that we have seen for the shape factor to get this F11. Okay, so for that, what we will do is we will take this concept first. That is F11 plus F12 is equal to 1. Okay, this is one property we have seen. The other property is F, the same thing for the other body also we will write F22 plus F21 is equal to 1. This is the first thing we know. And the other thing we know here is reciprocity theorem. That is A1 F12 is equal to A2 F21. Okay. So these are the two basic properties that you will make use of for solving this particular problem, or most of the problems this day you will solve it. Okay, if the question is asked this kind, this can be a potential 2 marks question for you. Okay, so you can solve simply if you can make use of these two concepts, that is the sum of the shape factors equal to 1 and the reciprocity theorem. So tell me what will be the value of F2 here. F22. What is the value? It's a flat disk. So second body is a flat
0.
disk. So it will be equal to 0. So F22 is equal to 0. So obviously, what will be F21? F21 will be equal to
1.
1 because F22 is 0. Now, let's make use of the reciprocity theorem. If we make use of the reciprocity theorem, you will get what is called as F12 using the reciprocity theorem. You can get F12. F12 will be equal to A2 by A1 into F21. And you know what is the value of F21? F21 value is 1. Okay. So simply put, F12 is what? It is the ratio of areas A2 by A1. So tell me what will be the area of 2? What will be the formula? Flat disk area. It's a circle area. Simply you can put pi r square. Okay. What will be the surface area of a hemisphere? It is 4 pi r square, and you have half of the hemisphere, half of the sphere. That is 4 pi r square by 2. You will take. So 1 by 2, 4 pi r square is the thing here. So pi r square and pi r square, I will cancel them. So what remains is simply 1 by 2. So you got the shape factor F21, sorry, F12 here. F12 is equal to half. And what you need is actually F11. So F, ma'am, F11 plus F12 is equal to 1. You need F11, that will be equal to 1 minus F12, that is equal to 1 minus 1 by 2, which is equal to 1 by 2. I hope this is clear to you. అర్థమైంది కదా? How did you find the shape factor? Is that clear? Shall we move to the next question?
Yes, sir.
Yeah. Next question. I'm writing it here. Determine the shape factor of inside body. Inside surface is the third thing. inside surface of semicircular duct with respect to with respect to itself when the heat transfer from the ends is negligible. So this question, I will leave it as assignment for you, or we will solve this question in the next class. With this, we will stop here.